In this video, we're going to be talking about Python's data structures. Now, Python has 5 basic data structures. You've already seen lists, and then there's an immutable form of lists called tuples that are more efficient to create, about the same to access. There are so-called double-ended queues, which are most efficient when you need to insert into the front of a list. Remember from the previous video that lists are implemented as arrays, and inserting at the beginning of a list is inefficient. So Python has a specific DQ class that makes it efficient to insert into the beginning of a list. Then it has dictionaries, which are actually hash tables. So it's a way of storing key value pairs. And then a restricted form of dictionary sets, which store unique keys. And they don't store a value, they just store unique keys. So for example, I might use the dictionary if I was going to count the number of occurrences of each word in a file. I might use a set if all I cared about was getting all of the unique words that were in a file. We're also going to talk about sorting in conjunction with data structures, because getting things in sorted order is important, and because we do not have trees in Python. You can implement trees, but Python does not have a built-in tree structure. So there's no way to keep things in sorted order unless you sort a sequence. Now, we already covered lists in a previous lecture, and that had some of the basic things of lists. So if you want a basic set of operations on lists, they are as follows. First, there is append, which, as you might imagine, appends an item to the end of a list. Then there's the plus operator, which concatenates two lists and creates a new list. If instead you simply want to extend an existing list, then you would use the extend command, and that would add list 1 to the end of the existing list. So plus returns a new list, extends modifies the existing list. If you want to insert something into the middle of a list, you would use the .insert index and val. Index is going to be the place at which the value is inserted. So for example, if I said .insert 0 in Brad, I would actually make Brad the first item in the list. Remember, lists are implemented as arrays, so this may not be an efficient operation, but if you're just prototyping, it's not bad. Then .remove is going to remove the indicated value from the list. In fact, the first instance of val from the list. So if there are multiple values of val, the remaining values will remain. .pop is going to return the either last element of the list if you don't specify an index, or if you do specify an index, it will return that particular element. In each case, it also removes that element from the list. Then .reverse will reverse a list, and this is not, these were all methods. This is a function, so delete will actually delete a element or a slice of a list. So for example, if I were to say delete a sub 0, that would delete the first element of the list. If I said delete ace2 of 5, it actually deletes elements 2 through 4. Remember, the 5 is not included in the slice. Now, frequently, we're going to want to do some set of operations, and then we're going to want to be able to sort a list. So sort's a big deal, and there's 2 ways you can sort a list. You can do it in place with the .sort command, or you can use it as a function and provide a list. So this does an in-place sort, so it modifies the list. This sorted returns a new list and doesn't modify the original list. And also, the sort.sort works only on a list, whereas sorted works on any sequence. So you could have, this could also sort. Sorted can be used with, for example, tuples as well as with a DQ. So the sort algorithm is stable, which means that if you have duplicate elements, the duplicates will appear in the same order in the sorted list as they appeared in the unsorted list. And it sorts in ascending order. So it uses alphabetical order if it's a string and numeric order if it's integers. If you want to sort in reverse, then you're going to use the reverse flag. And from now on, I'm just going to use the sorted command. So if I want to sort a list in reverse, I would say reversed or reverse equals true. Now, many times I'm not just going to I won't have a simple list of strings or of integers. I'll have something more complicated, such as a class, or maybe I'll have a tuple. So I'll want to be able to specify a more sophisticated way to do my comparisons. And I can use the key parameter to do that, and it expects a pointer to a function. Now, you can either create your own function, or more typically, you would create a so-called anonymous lambda function to do some sorting. So as an example, I'm going to create some tuples, and a tuple is, remember, just like a list. So instead of using square brackets, we're going to use parentheses. So we're creating tuples with 3 elements. Now we'd like to sort it, and let's say we want to sort it by age, which is the last attribute in our tuple. So the way we could do that is we could write sorted student tuples, and then say key equals lambda. So this creates an anonymous function. The lambda is what creates the anonymous function. Then what appears before the colon is the argument list. So in this case, student is the argument, and we are going to return student 2. So what happens is at the beginning of the sorting process, the key function is applied to each element, not once per comparison, but at the beginning of the sort. So conceptually, this key is applied to each of the 3 tuples once at the beginning of the sort, getting us 15, 12, and 10. And in our final sort, what would come out is Dave would be first, then we'd have the tuple with Jane, and then we would have the tuple with John. Now we could do the same thing, let's say, with objects instead of with tuples. So we haven't really talked about classes yet, but suppose that we had a class and these were these tuples, instead of being a tuple of 3 things, they had 3 attributes named name, grade, and age. And let's suppose that we want it to sort by age. Then what we could say is sort it. And now let's say the list was student objects. And again, we would say key equals lambda. Need a B here, lambda, S, and we would sort on student.age. Okay, so that handles primary sorting. And one thing to be careful about is don't say things like key equals, say, student2. The reason is that student2 actually returns a value, whereas key expects a pointer to a function. So make sure you do not do it this way. So the next thing we want to consider is what happens when we want to do both primary and secondary keys. And it's pretty easy to do. What we need to do is simply return a tuple with our key function. So for example, we could say key equals lambda. Now we're going to be doing it with our student tuples. Let's say we wanted to sort first by age and then by name. Then we could simply say student2, or actually in this case it is s of 2, s of 0. And you see we returned a tuple, and it will the sorting algorithm will automatically do the right thing. Now, this works only if we're willing to do things both in ascending order. Sometimes we don't want to do that. Sometimes we might want the primary, which I'm going to denote as P, to be ascending, and we might want the secondary key, which I'll denote as S, to be descending. Now things get a little trickier. If the secondary key is an integer, let's say here that we want it to sort first by name and then by age, and we wanted the age to be in decreasing order, we could have simply said s of 0 for the name, and then because the age was a integer or a number, we could simply invert it, and that would get us a decreasing sort. But if we're dealing with something like a string in the secondary key and we want it to be descending, then we actually have to do two sorts. So in that case, what we would do is we would first sort by the secondary. So first sort sequence on secondary. And then we would sort on the primary. And if you think about it, that will actually give you a sort on the primary key, and then the secondary keys within the primaries will be sorted. And the reason this works is because this is a stable sort. And so if you have duplicate secondary keys, they still appear in the same order when you do the primary sort. Now, because sorting on tuples and objects are so common, Python has introduced some helper functions which you can get from the operator module that allow you to actually get at the positional attributes in a tuple or the named attributes in an object without having to write lambda functions. So for tuples, there is a function called item getter, and remember it's from the operator module. And you simply give it one or more arguments that indicate the order in which you want things sorted. So this would say first sort by age and then by name based on our earlier example. And of course we'd have to say key equals in order to do that. And then for objects, it is called attribute getter, ATTR, and you give the name of the attribute. So now it would be age, comma, name. So those are good ones to remember. If you want to do it where you don't have to prefix item getter and adder getter with the name operator before using them, you'd have to say from operator, import, and then the name of the function. So for example, if I wanted item getter, then I would write item getter like that. And then I would not have to prefix item getter with the operator name. So that takes care of sorting. Now we're going to move on to functional operations on lists, because functional operations on lists are something that were adopted from functional programming languages. And there's three common operations that are very handy. They're called filter, map, and reduce. So we'll consider them each in order. So the first function is filter, and it takes a function pointer and a sequence, which I'll abbreviate as SEQ, and it returns all items of the sequence for which the function returns true. So returns a list of all items from sequence for which the filter function is true. So the function needs to take a single argument, and it's going to return true or false. Oftentimes this function will simply be a lambda function. For example, I might write filter and write lambda. If I want to filter all, and I just want people who make less than, say, $40,000, I might have lambda p. I might say p.salary less than 40,000. And some list then that presumably has a list of people objects with the salary being a named attribute. And this would return a list of all people whose salary was less than 40,000. The next one we're going to consider is map. So map takes a function and a sequence. Actually, it takes potentially more than one sequence, but in its simplest form, it takes one sequence and it applies the function to each element of the sequence and returns a list with the return values. So applies function to each item of sequence and returns a list of the return values. Okay, so for example, we might want to have a list of cubes for the first 10 integers. So we might say map and lambda x to the third power, and then range 1 to 11. And this is going to give us a list of cubes for the numbers 1 through 10. Now, where map is also very helpful is that we can apply map to multiple sequences. So let's say that we had two vectors and we wanted to add the vectors together like in a matrix. So what we could do in that case is write map lambda, say xy, x plus y, and pass in vectors 1 and vector 2. So what happens is for each pair of items in v1 and v2, it adds them together and returns a vector with the result. Now for this to work, the length of V1 needs to be equal to the length of V2. And you can have more than two sequences, just also have to obey the restriction that all sequences have the same length. The final function is the reduce function, and it's going to take a list of values, apply the function to it, and reduce it to a single value. So returns a single value, which it obtains by first calling the function on the first two items of the sequence. Then it applies it to the result, then to the result and the next item. And so on until it reaches the end of the list. So for example, let's say that we wanted to calculate the sum of a vector of items. Then we could say reduce lambda x comma y, x plus y, and our vector v. So let's say our vector was the elements 10, 20, 30, and 40. So what would happen is it would first apply the lambda function to the first two elements, 10 and 20, which gives us 30. Then the result and the next item, which is 30, so 30 plus 30 is 60, and then this result plus 40 is 100. And so the return value would be 100. And if you wish, you can provide a third value to reduce. So if you do that, let's say we said seek 1 because we wanted to perhaps start with a product for some reason. We didn't want to begin by multiplying the first two elements. I'm just saying as a for if. Then it would take that default value and multiply the first item by this default value, and then take the result and apply it to the second value, and so on. So if you provide this value, you already have, quote, a result to begin with, so it starts with the first item on the list. If you don't give it that default value, it applies the function to the first two elements of the list to begin with. So that completes the section on lists. And the remaining operations, or the remaining items we're going to talk about, we'll go a little more quickly with. So first of all, I didn't talk about stacks, but stacks can be implemented very easily in Python. You simply use a list, and you use the .append item in order to add an element, so that's the push. And you use .pop to pop an item off of a stack. Then you'll remember that we talked about double-ended queues. And you get a double-ended queue from the collections library. So you say from collections, import a double-ended queue. And the double-ended queue you can append either to the front or the back. So if you say .append, it appends a value to the back. And if you say append left of x, then it appends to the front, or append to front. Then you can say dot pop to pop from the back. And you can say dot push, pop left in order to remove from the front. And again, you should not use a list to implement a double-ended queue because the list is an array and it won't be as efficient. And if you wanted to create a DQ, you'd now simply say A equals DEQUE, like that, as long as you had first said from collections import DQ. So this would create an empty DQ that you could now insert into. Okay, the next data structure you've already seen is a tuple. So it looks like a list, except that your values are in parentheses. And they're immutable, which makes them more efficient than a list. So you can access them just like you would with a list using list notation, and you've already seen that. In general, they are going to be more storage efficient than lists because they know exactly how many elements they're going to contain. Whereas a list will typically over-allocate because it's going to have to handle appends. The accesses, the time for an access is roughly the same for both. And when you create a tuple, it's usually an order of magnitude faster. So creation of tuples is an order of magnitude faster. And that's because they can be built statically rather than dynamically. So they're an order of magnitude faster because they can be built statically. And you may argue that, well, you may not know the values until runtime, and that's true, but when Python sees it, it knows how many storage spaces it's going to take up, so it can statically allocate a fixed structure for a tuple. So in fact, if you're saying if I in, you should actually use a tuple because it will be faster for Python to create that. The other advantage of tuples comes when you are going to be unpacking multiple results from a function. So tuples give you the ability to return multiple values from a function. So say allow functions to return multiple values. So let's say I wrote a very simple function, I'll call it min-max, that's just going to take two arguments and it's going to return the minimum and the maximum of these two arguments. So I might say if x less than y, return x comma y, else return y comma x. So I'm returning in effect two arguments, and I could actually unpack this call by saying min max equals min max a comma b, and min will get the minimum value, whichever was returned here, and max will get the maximum of those two values. So remember this trick of tuples allowing you to return multiple values from a function. Now another very important data structure in scripting languages is dictionaries. And you'll also hear them referred to as hash tables or associative arrays or associative maps. But whatever they are, they're essentially hash tables. And they're built in to the language, meaning that there's built-in syntax for them. So you create them with curly braces. So I might have a set of telephone numbers, and I can create these telephone numbers. So Jack has the telephone number 4098, and Sape has the telephone number 4139. So I use curly braces, and then each pair has a colon separating the key and the value, and then commas separating the different elements in the dictionary. And you can create empty dictionaries by simply giving a pair of empty braces. So you can access a dictionary or an element of a dictionary just like you would an array, except now you give it the key rather than a positional number. And that works for either accesses or assignments. So I could say telephone Jack equals 4813, and that would update the value. You can also do members. So this was insertion. I'm sorry, this was assignment. So right here, that was assignment. That also works for insertion. So if there wasn't already a key with that value, it would do so. Then, if you want to do membership testing, you're going to use the in operator. So you could say if Guido in tel, and it would return true if Guido was in the dictionary and false otherwise. If you want to delete, you would use the del operator to delete a key. So for example, del, tel Guido would delete the entry containing Guido from the dictionary. So that gives us the basic insert, find, delete. And now you often are going to want to be able to flatten a dictionary because you may have to sort it. And there's three ways you can do that. There is dot keys, which it returns a list of keys. There is dot values, which returns a list of values. And often most helpful, dot items, which returns a list of the key value pairs. So if you needed to sort it, you could do something like, say, sort it, dict dot items, and then you could say item getter key equals item getter 0, and that would sort the dictionary based on the key. And if you said item getter 1, it would sort it based on the values. So this is a very handy way to quickly flatten the dictionary and then to sort it. Finally, we have sets. And sets are a unique collection with no duplicates. So you create them also with curly braces, except there is no value now. There's only a key. And you can provide duplicate values, but what you're going to get, if you were to look at it, X would actually just be the set 3, 6, 9. So it eliminates any duplicates that you might provide. You can also use the set function, so I could say set 3, 6, 9, or if I want to create the empty set, I just give it no arguments. And you have to be careful with sets, because if you try to say x equals an empty set of braces, this creates a dictionary, not a set. So if you want to create an empty set, you actually have to use x equals set like that. And you can use for testing, you can use the in function again. So for example, 3 in x. And sets provide the union operation. So you can say A or B. They provide intersection using the AND operator. And they provide set difference using the set difference operator. And finally, if you want to add an element to a set, you would say .add a key. If you want to discard a key from the set, you would say discard. And this will either discard it if it's present or simply do nothing if it's not present. And if you want to clear the set, you can use the clear command. This concludes our discussion of the different data structures that you find in Python.